This is the 8th in a series of 8 chemistry labs on the fundamentals of biodiesel. In this lab we will learn about Laboratory 8, density measurement of chemicals and fuels. Written procedures and background information for all 8 labs is provided on the Biodiesel Education website. The density of a substance is the mass per of an object divided by its volume. Density is a way of quantifying how heavy or light a substance is for a given amount of volume. For example, if 1 liter of vegetable oil weighs 930 grams, the density of the oil is 930 grams divided by 1 to equal 930 grams per liter. The mass of a substance is the sum of the masses of all individual molecules. Therefore, the density of a substance can be changed by changing the number of molecules occupying a unit volume. For instance, when a substance is heated, the heat energy increases the molecular vibration, pushing tightly packed neighboring molecules farther apart. As a result, a given number of molecules occupies more volume without increasing its mass. Therefore, when volume increases without increasing the mass, the density decreases. When 2 substances are mixed together, several things could happen. Let's imagine mixing substance A with substance B. If the intermolecular distance of the substance A is large enough that substance B can snugly fit into the void, the density of the mixture will be higher than that of substance A. This also holds true when a chemical compound is dissolved. For example, quite a lot of salt can dissolve in water without increasing the water volume. The process increases the density of the chemical mixture. This is the reason salt water is about 2.5% heavier than fresh water. In the second type of mixture, the voids are not big enough for substance A to accommodate substance B. In this case, the mixture volume is the sum of the volume of the individual components. An example of this is the mixture of atmospheric gases. In the third type of mixture, component A chemically reacts with component B, and the product of the reaction may have lower or higher density depending upon the chemical reaction. The density of the product depends on the chemical structure of the molecule formed. The density of matter in the gaseous phase can be calculated mathematically from its molecular formula. 1 mole of gas always occupies 22.4 liters at standard temperature and pressure. Therefore, the density of a gas at standard temperature and pressure can be calculated as shown here. However, the density of liquids and solids is not as straightforward as that of gases. In this lab, we will begin by calculating the mass of methanol needed and how much biodiesel and glycerol are produced from 100 milliliters of soybean oil reacted. The biodiesel transesterification is given by this chemical reaction. From previous discussions, we know that the density of vegetable oil is about 930 grams per liter. From the transesterification chemical reaction, we can simply divide 3 times the molecular weight of methanol by molecular weight of vegetable oil and multiply that by 930. Similarly, the mass of biodiesel and glycerol produced can be calculated as shown here. Now, take the temperatures of soybean oil, biodiesel, and petroleum diesel and ensure that they are all at room temperature. If not, wait until they all come to room temperature. Pour the 100 grams of vegetable oil in a measuring cylinder using a dropper and a weighing scale. Then pour calculated mass of biodiesel produced from 100 grams of vegetable oil in a separate measuring cylinder using a dropper and a weighing scale. Finally, pour 50 grams of petroleum diesel in the third measuring cylinder using a dropper and a weighing scale. Observe the volume of biodiesel fuel produced compared to the volume of the soybean oil used to make the fuel. Record your observations along with the following measurements: volume of soybean oil used to make biodiesel, volume of biodiesel produced, and volume of petroleum diesel. Now, carefully pour biodiesel into petroleum diesel until the mixture weighs 100 grams and measure the volume of the fuel mixture. calculate the density of the soybean oil, biodiesel, and petroleum diesel. Thank you for watching the Laboratory 8 Density Measurement of Chemicals and Fuels lab on the fundamentals of biodiesel. Please go to the Biodiesel Education website for a complete written transcript of this lab exercise.